Hi guys, welcome to my channel. In this video we are going to solve a question about the engineering hydrology, and the question will be from the chapter of BASIN. So let's solve the question. Cumulative rainfall values of a storm which took place over a basin of 700 kilometers square area and resulting total hydrograph ordinates are given below. Assume a constant base flow of 28 meter cubic per second and determine the depth of surface runoff, Hyetograph of the storm, phi index, the duration of the excess rainfall, total infiltrated water. So let's start with the first one. And for the first one, we are going to use this column, okay? Because you can see now this is the discharge. It passes in the river. They measured it. So between the specific hours. So we have a constant base flow. So this one is the before the rainfall, the normal flow of the rainfall, the normal flow of the river, 28 meter cubic per second. Normal flow of river, okay? This is the normal flow of river, so this is the base flow. We are going to subtract from that much for this one and for this one. All one by one, we are going to subtract from them. And we are going to obtain the discharge of the surface runoff. Okay, if we got the discharge of that much, we are going runoff, we are going to obtain the depth of it. So 1 second. Yeah, for example, this is Q. Okay, this is Q as meter cubic per second because it's going to be discharged. 28 minus 28 is going to be 0. 28 minus 28, 0. And this is going to be 52. And this is 172. And this is 412. This is 612. And this is 502. This is 307. And this is 192. And this is 147. This one is actually this, okay? And this is 122 minus 28. It's going to be 94. And this is 32. And this is 0. So now we obtain the discharge of a surface runoff passes in the river. So now we are going to take the summation of all discharges, and we are going to obtain Q equal to 22 meter cubic per second. Now we obtain discharge, so we are going to obtain the volume from this discharge, and we are going to determine the depth of surface runoff. So what's going to be volume? Volume will be equal to 22, this is meter cubic per second, multiplied 3,600 second, okay, for 1 hour. So multiplied 2 hours. Why? Because you can look at here, the differences between the two measurements is 2 hours, okay? So this is going to be 18,158,400 meter cubic as the volume of that surface runoff. So what is the area? What is the area? Look at here, area is given, area of basin, 700 kilometer square. So when we need to convert it to meter square, it's going to be 700 multiplied 10 power 6 meter square as the area of the basin. So now for the depth of surface runoff, we are going to divide the volume to the area. It's going to be 18,158,400 multiplied 700 multiplied 10 power 6 equal to 0.026 meter as the depth of surface runoff. So now let's convert it to millimeter. It's going to be 26 millimeter as H, okay? So now we determine the depth of surface runoff. Let's solve the second part. What is the second part? I'm going to solve the second part here. This is going to be T, this is going to be delta D, this is going to be delta T, and this is going to be intensity. And this is hour, this is millimeter, and this is also hour, and this is millimeter to hour. Okay, so for this one, for time, 0, 2, 4, 6, 8, and 10. Okay, and delta D, look at here, delta D between 0 and 2 is 0, and between 2 and 4 is 22, between 4 and 6 is 26, between 6 and 8 is equal to 6, between 8 and 10 is equal to 0. And now let's write the delta T. Look at here, the differences between the two specific hours, between the two measurements, are 2 hours. So let's write it here, 2 hours. All will be 2 hours, and 2 hours, and 2 hours, 2 hours, and also 2 hours. So the intensity would be, we are going to divide the delta D to delta T. So we are going to obtain, this is going to be 0, O over 2, and 22 over 2, 11, and 26 over 2, it's going to be 13, and 6 over 2, it's going to be 3, and O over 2 is going to be 0. So now let's construct the Hyetograph here. Okay, I can't draw the straight line, sorry. This is 0, this is 2, 4, 6, 8, and 10. Between 0 and 2 is 0. Okay, now you can see. Between 2 and 4 is 11. Between 2 and 4, for example, this is 11. Yeah, we can draw it like that. And this is 11. And between 4 and 6 is 13. Between 4 and 6 is 13. And between 6 and 8 is 3. And also this is 0. Now we construct the Hyetograph of the storm, and this is intensity, and this is time. So this is 3, because you know 6, between 6 and 8 is 3. So let's check for the third part. What is third part? The phi index. So phi index, how we are going to determine the phi index. Phi index is, now look at here, for example, the phi index is here. Okay, phi index, it specified the water that will act as surface runoff. Okay, so that will start as an action in the surface runoff. So for example, this is phi index, and we are going to write it as an x. Okay, because I'm going to use in a equation. So let's check. Yeah, for example, this is phi index. We are going to assume that it is 3. Okay, I'm gonna show you something that how it is, so how it will be fun. So for example, this is 3, and until 3, what is this? This is 2 multiplied 6, so multiplied 3 will be 6, minus 22, 22 minus 6 will be 14, plus, and I'm going to calculate this area. Okay, and we are going to assume that the phi index is 3. So this is 2 multiplied 13 minus 3 is 10, 2 minus 10 is 20, 34 is greater than 26, so it is not 3, it is above 3, right? So if it is above 3, I'm going to apply an equation. For example, 11 minus, if it is above 3, so this is x, 11 minus x multiply 2 plus 13. Look at here, 13 minus x, this x, and this is 13, 13 minus x multiply 2 equal to 26. That's correct. Look at here, 13 minus x, this length multiply 2, and this area plus this area, 11 minus x multiplied 2, this is 2 hours, then this one is this area, so it's going to be equal to 26, and the equation is right. So this is going to be 4x equal to 22, and due to this one, x equal to 5.5. Okay, and this is millimeter. So now we determine the phi index. Phi index is 5 at 5.5 millimeter. So now the third part also solved. Let's determine the fourth part, the duration of excess rainfall. So this is going to be, for example, the duration of the excess rainfall, the water that is in the surface runoff. Okay, the water except of infiltration, and look at here. This is 2 hours, and this is 2 hours. So the totally 2 plus 2 equal to 4 hours. The range, actually, yeah, the hours range above phi index, the water is acted as surface runoff. I'm going to write here, the water is acted as surface runoff as hours, okay, because they ask for as hours. So let's solve the last part, the water below the phi index. Sorry, the phi index. What is the water below the phi index? Look at here, phi index at the 5.5. okay, 5.5. So 5.5 multiplied, for example, this is going to be part E, okay, the last part. Look at here, the total infiltrated water. So the water below the phi index. So what is that? Look at here, this is 5.5 because the phi index was at the 5.5. 5.5 multiplied 2 plus 5.5 again for this part, okay, for this part, multiplied 2 and plus 3 multiplied 2, and this is going to be equal to 28 millimeter. Okay, the water below the phi index is total infiltrated water. And now the question is solved. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. See you for the next question.